Inferring properties of a polynomial function from its graph. Below here are two examples. There's example A and example B. Both of them are called f of x, but clearly they are different polynomials. One of them has 2 zeros, and this one has 1, 2, 3 zeros. You can clearly see that they are different polynomials. So we'll look at these one at a time. Let's separate the page here. For part A, the function f is decreasing over which intervals? So we're looking at this function from left to right. It's very, very important that you actually copy this graph down on your own sheet of paper and then draw the arrows. And then, label the number line as well as you can. But more importantly, draw the arrow so that it matches the domain and range of the function. In this case, we are worrying about the domain in part A. Part A of A, I should say. The function f is decreasing over which intervals? Notice it's decreasing here from negative infinity up to negative 9, and then it starts increasing. So when we're talking about decreasing, we're talking about decreasing from left to right. Now it's increasing, it starts decreasing starting at negative 6. So we're going to use parentheses, negative 6. It actually hits a peak when x equals negative 6. So we're not going to include negative 6, but as soon as you go to the right side of negative 6, it starts decreasing again, and it goes all the way up to 0. So let's fill in this bubble here. It's better to just write this out on your sheet of paper instead of trying to bubble things. Bubbling things does not help you learn. It's almost better to write things out. Actually, I shouldn't say almost. It's always better to write things out. It also decreases from 5 to 8. So the next one is this one, 5 to 8 here. So for part A, I'm actually going to write this in a complete sentence. Part A of A, f is decreasing on the following intervals, and we can simply list them. Negative infinity to negative 9, negative 6 to 0, and then not negative 5, just positive 5 to 8. Okay, the function f has local minima at which x values? Where are their local minimums at which x values? You can see them from the graph. And so we have a local minimum at x equals negative 9. We have a local max at x equals negative 6. We have a local minimum at x equals 0. We have a local maximum at x equals 5. And we have a local minimum at x equals 8. So we're really concerned about the minimum values. And once you see the minimum values, then we read the corresponding x values. Here we go. Let's try this. So at x equals negative 9, x equals 0, and what? X equals 8, there are local minimums, or local minima. What is the sign of the leading coefficient of the polynomial f? In this case, f of x does look like a times x to the fourth, where a is positive. So the sign here is positive. Which of the following is a possibility for the degree of f? It looks like x to the fourth, but of course, any even degree for a polynomial will have similar end behavior. So in this case, our answer is going to be 4, 6, or 8, or 10, and so on and so forth. In this case, 4, 6, and 8 were the possibilities. So I'll go ahead and circle those. 4, 6, and 8. I'll write them bigger for you as well. And why don't you go ahead and try example B? You could pause the video and then check your answer towards the end by unpausing the video. First thing you want to do is actually redraw this graph on your own sheet of paper and make sure you draw arrows at the end of a polynomial to match the domain and range. For decreasing intervals here, we have quite a few intervals. If you're reading the graph from left to right, you're going to see that it's going for these two intervals here. There should be one more. Yeah, there's 7 to infinity. So it's better to write this out on your own sheet of paper. We could say f is decreasing on the following intervals. -9, -6, -2, 3, and 7, 8. Another good reason to write more notes or complete sentences in your homework is so that when you go back and study your homework, you should be able to memorize the instructions that were given. Okay, if you memorize the solution, then you might as well memorize the instructions to get the complete language. Okay. Part B here says the function f has a local maxima at which values. If there is more than one value, separate them with commas. I'm going to just go ahead and write a complete sentence in here. It'll be easier. At x equals -9, x equals -2, and x equals 7, there are local maxima. There are local maxima. Okay. Like I said before, it's better to just write them in complete sentences. It makes more sense. I'm just going back and circling some of those complete sentences. Helps you really understand vocabulary. What is the sign of this leading coefficient? We're on part C. Well, this actually looks like, this looks like an opposite of x to the 4th. Oops, that's not the opposite symbol. Meant to write the similar symbol first, and then we have negative, or the opposite of x to the 4th. So in this case here, the sign of the leading coefficient is negative. And we can write that in a complete sentence as well to learn the vocabulary. The sign of the leading coefficient is negative, and it will match the negative symbol in front of the x to the 4th. Which of the following is a possibility for the degree of f? It is looking like degree 4, and of course every even degree polynomial will have the same end behavior of x to the 4th. So in this case, it's actually the 3 even numbers that are given. If they gave you 10, 12, 24, 48, or 52, you would be able to select those even numbers as well.